Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. This book contains 230 problem solving questions. It has 174 data sufficiency questions. We have solved every single one of these problems. If you're interested in watching the original solutions to any of these problems, you will find the original solutions to these problems on day number 1 through 250. Right now we are in the process of redoing the problems, and we are on page number 279. Let's start to it. Page number 279, the very first problem on the page number 279, or rather the very first problem in the second column of page 279, number 50. It says that we have two numbers, x and y. We are told that they are positive integers. X and y are positive integers. And the question is very simple, very straightforward. Is x over y more than 1? That's all they're looking for. Is x over y more than 1? Let's see what they tell us in the first statement, shall we? In the first statement they tell us that x times y is more than 1. Well, if x times y is more than 1, is that going to tell us if this quantity is more than 1? Let's find out. For example, we are told that x times y is more than 1. Maybe it is 2 times 3. 2 times 3 is more than 1, in which case x over y would be 2 times 3. And in that case, it's going to be less than 1. Or maybe it is 3 times 2. It's very simple analysis, there is nothing to it. In this case, x times y would be more than 1. X times y would be 3 over 2. In this case, x over y is 3 over 2, which is more than 1. So is it more than 1 or is it less than 1? Simply knowing that their product is more than 1 does not enable us to ascertain whether or not this quantity is more than 1, x over y. The first statement is, as we can clearly see, not sufficient. It's not sufficient. AD, BCE. AD, BCE. Now that we have established that the first statement by itself is not sufficient, we know now that the answer cannot be A or D. Answer would have to be either B, C, or E. Let's look at second statement. In the second statement, they tell us that their difference is positive. In the second statement, they tell us that their difference, x minus y, is positive. Well, if x minus y is positive, that implies that x would have to be more than y. And if x is more than y, then x over y, because we just know that x is more than y, this quantity would have to be more than 1. Because the numerator, we are told, the top part, the numerator, we are told, is more than the denominator. So this fraction, whatever this fraction is, it's got to be more than 1. Second statement by itself does the job. The first statement was no good. The answer to this problem turns out to be B. The answer is B. Let's move on then. Next problem in the same column there, number 51 there. Number 51. Just give me one brief second. Number 51. Number 51 says that we bought something for X dollars. And then we are told that we're going to sell it for Y dollars. The question is, profit is what percent of the cost? Profit is what percent is the cost? That's what we have to answer, and let's see what they tell us in the two statements. In the first statement, they tell us that y minus x equals 20. Y minus x equals 20. Y, as we know, is the amount that we sell it for. So y is the selling price. X, we are told, is the amount that we bought it for. So that's our cost. And therefore y minus x is the difference between what we sold it for minus what it costs us to acquire it. But that difference represents our profit. So this amount is the profit. But that's not enough. We're not interested in finding out what the profit is. The question is, what is the profit as the percentage of the cost? profit as a percentage of the cost would be profit over the cost times 100. Well, profit we know is $20. The top part we know is $20. So this amount, profit over the cost, the top part we already know is $20. Our profit is $20. But what is our cost? We bought it for X dollars. What is that X? We do not know what that X is. We do not know what the cost is. And until we know the amount that we paid to acquire it, until we know the cost of the product, we cannot figure out the profit as a percentage of the cost. The first, why does it say first statement? Is that the first statement? That's the second. That's the first statement. I don't know why it said the second statement there. The first statement is no good. A, D, B, C, E. The first statement is no good. It's not enough. Also cannot be A or D. Let's look at second statement. Second statement tells us that y over x. It tells us that y over x equals 5 over 4. Y over x equal, it tells us is 5 over 4. Now listen, there are two ways we can go about it. Y we know is y is what we are selling it for. That's our selling price. So this is selling price over the cost. This is the ratio of selling price over the cost. Well, so what it tells us is that, what this ratio tells us is that, listen carefully, okay? There are two ways we can go about it. I'm showing you the quicker way first without actually doing any work. What this tells us is that for every $5 that we sell the product for, it's costing us $4. Or if you're selling it for $5 and it's costing us $4, $1 is our profit. So here, our profit is simply $1 on every $4 of cost. Well, $1 on every $4 of cost, that's 25%. We are done. So the question here is, what's the profit as a percentage of the cost? The profit is 25%. Second statement does the job. Second statement does the job nicely. The answer is B. The answer is B. Now, if you did not like what I just did here, if you feel that this was sloppy and this is not something that you want to do, if you want to be a good boy or good girl and want to do it the proper way, then we can do it proper way, which is simply the profit as a percentage of the cost would be simply our profit divided by the cost times 100. Our profit, as we know, is y minus x. We sold it for y dollars. We bought it for x dollars. That's our profit. Over the cost. Cost is x dollars. We're buying it for x dollars. Times 100. Times 100 because we are figuring out the percentage. This is the profit as a percentage of cost. The profit is y minus x. The price that we're selling it for minus what it costs us to buy it. That difference is our profit divided by the original cost divided times 100. That's it. Now we can work it out. This quantity is same as y over x minus 1. Y over x minus 1, which is y over x. We are told right here. We are told y over x is 5/4. We are told that y over x is 5/4 minus 1. 5/4 minus 1 is 1/4. 1/4 times 100. Of course, we have to do times 100. Otherwise, we're going to end up with a decimal 0.25, which is 25%. But the point here is, second statement is quite sufficient. But we didn't have to do all of this mumbo jumbo the algebraic way. It's not necessary. Just look at it. It's a $5. You're selling it for $5. Something you're selling it for $5. Something that you acquired for $4. Obviously, you're making $1 profit on a $4 investment, on a $4 cost. 25% profit as a percentage of the cost. Let's do the next one, shall we? Number 52. Sometimes it pays to just keep it simple and keep on moving. Do you understand? Let's do number 52. Before we do 52, let's do the ritual as we always do. Give me 1 second to take a sip. We are told again that x and y are positive. We are told that x and y are positive. Now pay attention here. It does not say integers. It does nowhere in the problem it says that they are integers. All it says is that x and y are positive, but not necessarily integers. Do you understand? We cannot assume that. It doesn't say that in the problem. All we know is that x and y are positive quantities, but not necessarily integers. The question is this statement true? Is x less than 10 and y more than 10? Very interesting question. Is this true? Let's find out, shall we? Let's look at the first statement. The first statement tells us that x is less than y and x times y is 100. A, D, B, C, E. Now, in a question like this, when it's a little bit more complicated, it does not hurt, it's always a good idea, it's always a smart idea to quickly glance at the second statement also, just to make sure that one is not easier than the other. Now, if it turns out that one statement is easier than the other, if it turns out that the second statement is in fact more straightforward, if you feel the second statement is something that you can handle very easily, do the damn thing first. There is no reason why you should start with the first statement just because it happens to be the first statement. If you look at the second statement here, second statement tells us this part, okay, watch there. Second statement tells us this part. Second statement tells us that x squared is less than 100 and y squared is more than 100. Now what do you suppose? What do you suppose if you were to take this bloody thing and take the square root of the entire inequality? What do you suppose we will get? If we take the square root of the entire thing, the square root of x squared is x, square root of 100 is going to give us 10, square root of y is y, and there you go. That's exactly what they're asking. They're asking is this true? To which the answer is staring in our face. Statement number 2 clearly tells us that it is. It's very easily. One-step process. As a matter of fact, we don't even have to pick up the pen. Just look at the bloody thing and you will see that if x squared is less than 100, then x would have to be less than 10. And if y squared is more than 100, then y would have to be more than 10. It's right there. So in this case, we started with statement number 2 first because it was very straightforward, very simple. It's perfectly okay to do that, but there is one thing that you have to keep in mind, which is if you're going to adopt this strategy, if you switch, and if you decide to start with second statement first, then write down this plan here, A, D, B, C, E, and immediately, as soon as you decide that you're going to work on statement number 2 first, immediately switch the A's and the B's. The B ends up here and A ends up here. We just found out the second statement by itself. Is quite sufficient. That tells us that the answer cannot be A, C, or E. Answer would have to be either B or a D. Now, after this point, after this stage, if you decide at this point that the first statement is in fact too difficult, you do not know how to handle it, you do not know how to start it, you do not know what to do with it, or if you feel that you're running out of time and you don't want to invest any more time into it, that's all right. That's quite all right. You have a 50-50 chance of being right. A 50% chance on a question where you only did half the work is a fairly good investment in my opinion. Do you understand? So just pick one in that scenario and just move on. Of course, we're going to finish it. So now we're going to do the first statement. Second statement is done. Second statement is done. Now let's take with the first statement, okay? You just have to analyze it logically. We are told that x times y is 100. X times y is 100. There are only three possible scenarios where this would be true. Listen very carefully. There are only 3 possible scenarios where this will be true. One is that x times y equals 100. One is that where x and y, they are both 10. X is 10 and y is 10. 10 times 10 is 100. Of course, anybody can see that. But they have ruled out this scenario. They have ruled out by this scenario by telling us that one is less than the other. Don't read this thing, don't read the damn thing as x is less than y. X and y, these sounds that I'm making with my mouth, x and y, they have no meaning, they are just names. Do you understand? We are not attached to one or the other. We don't really give a, well, I'm not going to finish my sentence. We don't care which one is bigger. Do you understand? One is bigger than the other. That's what it tells us. This tells us that they cannot, all this tells us is that, this is their way of saying, they cannot both be equal. They have ruled out this scenario. But then it's very straightforward. The only other possibility is that here x times y and x times y, either x is less than 10 and y is more than 10. Something less than 10 times something more than 10 is quite possible to be 100. Of course, their product would be 100. You can clearly think of 2 numbers. For example, I'm just going to make up. Okay, I'm going to make something up. How about 11.4 times 100 over 11.4? I'm just making it up. Do you understand? I'm being silly. 11.4 times 100 over 11.4, of course if you multiply them they will cross out and product will be 100. And 100 divided by 11 point is something less than 10. So either this is true, or maybe x is more than 10 and y is less than 10. Those are the two possibilities. Again, given the fact that here they clearly tells us that it is x that is less than y, this is where the names come into play at this point. X is less than y, here x is more than 10, y is less than 10, they have ruled out this scenario. So the only possibility is this, where x would have to be something less than 10 and y would have to be something more than 10. Let's put that down here. So this implies that x would have to be something less than 10 and y would have to be something more than 10. Well, how do we put them together? How do we put them together? Well, if you put them together, what it translates into is this. X is something less than 10. X is something less than 10. And y is something more than 10. Voila. Question is this true? The answer is yes, it is. Yes, it is. We just found out. X is something less than 10, x is something less than 10, and y is something more than 10, right here. That's the only way their product is going to be 100. Because there are only three ways that can be true. Either they are both equal to each other, or x is less than 10 and y is more than 10, or x is more than 10 and y is less than 10. X cannot be more than 10 and y cannot be less than 10, in this case x would end up being more than y. We are told that x is less than y, so this is what we're looking at, which means x has to fall to the left of it and y has to fall to the right of it. And that's all there is. We are done. Turns out the second statement by itself is also quite sufficient. The answer to this question is D. Do you understand? It's always a good idea. It's always more fun to have a question that makes you think a little bit, because a lot of the time they give you questions, they're just too silly, they're too simple. Let's go to the next one, shall we? Number 53. Number 53. Oh, 53 is another fun one. 53 is another good one. Let's see what we can do. X, we are told, is an integer. So here we are told that x is whatever the hell it is a whole number. The question is 9 raised to x plus 9 raised to negative x equal to b? Oh, what an interesting question. What an enigmatic, esoteric question. Enigmatic and esoteric, we say. Enigmatic and esoteric, we say, only because we know nothing at this point about x and b and all that until we read the two statements. Perhaps it will not be that enigmatic after we find out what information they give us. Let's look at the first equation, first statement rather. In the first statement they tell us that 3 raised to x plus 3 raised to negative x equals b plus 2. Tell you what, let's start the game with a simpler one. Look at the second statement. If you look at the second statement tells us that x is positive. Do you really think the simple fact that x is more than 0, knowing that alone that x is some positive quantity, is going to enable us to answer if this is equal to b? Answer, of course, is no. For one thing, this bloody thing makes no mention of b. So how are you going to sit there and tell me whether or not this is true when the second statement makes no mention of b? Second statement by itself does no good. Second statement by itself is no good. A, D, B, C, E. A, D, B, C, E. One more time, we have switched. We have started with the second statement. Answer cannot be A, C, or E. Answer would have to be B or D. Answer would have to be, we just figured out the second statement is no good. Oh my God, I made a huge boo-boo here. I caught myself because I just said that the answer is going to be either B or D, but D means that each of the statement by itself is sufficient. Each of the statement bloody well is not sufficient by itself, because we just said second is not sufficient by itself. That's how I quote myself. Let me redo it. A, D, B, C, E. This is how you mess up, because if I do something out of routine, out of script, then there is a chance that you will mess up. I have a habit. This is my habit, and as soon as I start with the first, as soon as I decide to start a second statement, I make the switch right away. A becomes B and B becomes A. We just found out the second statement is not sufficient by itself, which means answer cannot be B or D. It would have to be either A, C, or E. Answer would turn out to be A if it turns out that the first statement by itself turns out to be sufficient, or if we decide that putting them together perhaps helps us somewhere, or if it turns out that putting them together still does not get us anywhere, then it will be E. Let's look at the first statement. But we already know it's either A, C, or E. Let's look at the first statement. I should not have made it so crowded here. I'm going to do it one more time. A, D, B, C, E, B, C, E, B becomes A, and A becomes B, B and D. It's either A, C, or E. I'm going to erase this thing because I need the room. Now, what we are about to do, I just want to warn you that it is not for everybody. If you do not have, if you're not good at algebra, then this is going to give you some trouble. Do you understand? And if a problem gives you trouble, and if you feel that I'm going too fast, that I did not do a very good job explaining something, that's why the original solutions are there for. In the original solutions, we went at a much slower pace, and I explained everything in a lot more details. Here I'm not going to do that, you understand? We're just going to solve it. If you have trouble, you can watch the original solutions. So here's what we do. We take both sides and we square it. Okay, if you square both sides, the formula that we get is a squared plus 2ab plus b squared. Now this is the part I really didn't want to do, because if this is what I meant by explaining. Your a is 3 raised to x. So 3 raised to x squared plus 2 times 3 raised to x times b, which is 3 raised to negative x plus 3 raised to negative x squared. And that quantity will simply be b plus 2. 3 raised to x squared is same as 9x, 9 raised to x plus 2 times 3 raised to x minus x, 3 raised to x minus x, x minus x plus 9 raised to negative x, and that equals to b plus 2. Perhaps this thing is not as bad as I thought. This thing actually turns out it's not as bad as I thought. Now 3 raised to x minus x, 3 raised to x minus x is this thing is 2 times 3 raised to 0. And we know that any number raised to 0 is just 1. Any number raised to 0 equals 1. Any number, doesn't matter. So here 3 raised to 0 is just 1, so this quantity is just 2 times 1, which is just 2. So what we end up here, actually, this is actually much simpler than I thought it would be. This is actually much simpler than it turned out, than I thought it would be. That's it, we are done. We see a 2 here, we see 2 here. If we subtract 2 from both sides, 2 cancels out, and we end up with 9 raised to x plus 9 raised to negative x equals b, which is exactly what they were asking. Is this quantity true? The answer is yes. The answer is yes. The answer is A. The answer turns out to be A. The second statement the first statement by itself, does the job quite nicely. The answer is A. The answer is A. That's it. Give me a break and we'll go to the next one, number 54 in a second. I was actually very surprised. I thought it was going to be a little bit nastier, but it wasn't nasty at all. Number 54. We are told that we are going to charge F cents for the first mile, and then we're going to charge M cents for each additional mile. The question is, how much for a 10-mile ride? How much for a 10-mile ride? If you get in the cab, of course, as soon as he turns the meter on, you have to pay usually a big chunk, a large amount for the very first mile, and then after that, the increment, the marginal cost, the cost of each additional mile is lower than the cost of the first mile. That's what this is. The first mile is going to cost you F cents. Each additional mile is going to cost you M cents. Question is, how much are we going to end up paying if we take the taxi for 10 miles? Of course, we cannot answer that question, how much the 10-mile ride will cost, until we know something about M and F. Let's see what they tell us. The first statement tells us that it costs 90 cents for 2-mile ride. How do we interpret this thing? All we know, all this tells us, 90 cents for a 2-mile ride. 2-mile ride means the first mile. 2-mile ride means the first mile plus an additional mile. And that equals 90. And that's all we get out of it. That's all we get out of it. So what we have at this stage, is one equation. One equation, F plus M equals 90, and 2 unknown. Obviously, we cannot solve for 2 unknown with one equation. The first statement is not worthless. First statement actually will come in quite handy, perhaps, but it is not enough. The first statement is not sufficient. It's not sufficient because we have 2 unknown and only one equation. The first statement is not enough. A, D, B, C, E. A, D, B, C, E. Because of the fact that we just established that the first statement is not sufficient, answer cannot be A or D. Answer would have to be either B, C, or E. Let's look at second statement. Second statement tells us that we're going to pay $1.20 for a 4-mile ride. Second statement tells us that we're going to pay $1.20 for a 4-mile ride. Again, a 4-mile ride consists of the very first mile of the ride and 3 additional miles. And for which we are paying M cents. So 3 additional miles are going to cost M times 3 cents, whatever the value of M happens to be. And the first mile is going to cost F cents. And together we are told that the cost is 120 cents. Together we are told is 120 cents. There is your equation right here. Again, we have the same exact situation as before, same exact problem as before, which is we know that we have this equation, one equation, F plus 3M equals 120. We have one equation here, but 2 unknowns. We cannot do anything with it. We cannot solve for F and the M, the values of the F and the M, and until we have the unique value of F and the M, we cannot answer the question how much the 10-mile ride is going to cost. So second statement by itself is also not enough. Answer cannot be B. However, when we put them together, there we go. Together, it will do the job nicely. Because we have 2 equations and 2 unknown. Or to be more precise, if you want to be pedantic, one would say that not only we have two equations, that's not enough. We must emphasize, we must point out that we have 2 independent equations. And because we do have 2 independent equations, we can solve for the 2 variables. Putting them together will do the job nicely. The answer is C. In the real exam, we don't actually have to waste our time figuring out the values of the F and the M, because nobody is asking us exactly how much it costs to have a 10-mile ride. That is not what they're asking here. What they're asking here is, do we have enough information to be able to figure out the cost of a 10-mile ride if we had to? To which the answer is, yes, we do have enough information if we extract the information from both statement 1 and 2, put them together. And that's answer choice C. Now, what we are about to do is actually a sheer waste of time. Do not do it in the real exam. It will be foolish. It will be a damn silly thing to do. We're just going to do it out very quickly, just for learning purposes. Well, we know that F plus M equals 90, which means M equals let's put it for f, which means f equals m minus 90. 90 minus m. I'm going to put it in here. 90 minus m. So we have 90 and then negative m and a positive m, which is 2m equals 120, and that means 2m equals 30 and m equals 15. And all of that was unnecessary, you understand? All of that was quite unnecessary. Quite unnecessary, it's a waste of time. Once we figure out the value of m, we can figure out the f, which is 90 minus 15. 90 minus 15 is going to be, 90 minus 15 is going to be, whatever that is, 75 cents for f. The first mile is going to cost you 75 cents. Each additional mile is going to cost you 15 cents. Therefore, the cost of a 10-mile ride is going to be the 75 cents for the first mile, and then the rest of the 9 miles are going to cost you 9 times 15. There's your answer. But that wasn't necessary, you understand? That was a waste of time. Let's move on then. Let's move on. Number 55. The penultimate problem on the page. Did we ever learn the word pedantic? And then we will see how we use this in the context. But first we have to see if we actually learned it in our vocabulary lessons. The word pedantic. I'm looking at P here. Just give me 1 second. But damn it, we have not learned it. Pedantic means to be overly scholarly. If one is being pedantic, one is showing off one's knowledge too much. To have an ostentatious display of one's knowledge is to be pedantic, to be overly scholarly. So what I said is that we have 2 equations and we have 2 unknowns, and of course we can solve for the 2 unknowns with the 2 equations. And then what I said was, if one wanted to be pedantic, one would go on and explain that not only we have 2 equations, but these 2 equations are independent, which is very important actually. Do you understand? The equations of course need to be independent. Let's move on then. Enough of the talk. 55. Perhaps I'll remember it to cover it in the future, the word pedantic. It's a good word. Number 55. In number 55, we are told that the net income equals gross income minus the deduction. That's a novel idea. The question is, by what percent did net income change? Let's look at the first statement, shall we? By what percentage did the net income change if we are told that net income is defined as your gross income minus all the deductions for taxes and pensions and health insurance and what have you. Let's look at the first statement, shall we? The first statement tells us that the gross income, we are told, has gone up by 4%. Now, do you really think that knowing that the gross income has gone up by 4% is going to enable us what was the percentage change in our net income? Of course not. That's silly. Simply knowing the change in gross income is not going to tell us what happened to our net income until we know something at all. Well, we actually knew, even if we knew what happened to the deduction, we would still have to know the figures, dollar amounts, in order for us to figure out the percentage change in the net income. The first statement is not sufficient. A, D, B, C, E. The first statement is not sufficient. The answer cannot be A or D. Let's look at second statement. Second statement tells us that the deduction have gone up by 15%. Again, this is silly. Knowing the deductions have gone up by 15% is not going to do anything. That's not going to tell us how much the net income is going up. Answer cannot be D. And even if we put the 2 statements together, knowing that one has gone up by 4%, the other one has gone up by 15%, that doesn't tell us what the change in net income is. We do not know any figures. We need to know the dollar figures for the net income before and after, before we can figure out the percentage change in the net income. If putting the 2 statements together also does not get us anywhere. The answer is E. The answer is E. Let's move on to the very last question on the page, number 56. Number 56. Number 56 is very straightforward, very simple. The question is, how much is z? It's a triangle, for crying out loud. Here's your x, here's your y, here's your z. The first statement tells us that x plus y is equal to 139. Well, if x plus y is equal to 139, and this 139 actually plays no role at all, plays no absolute, no importance at all, you can change it to any other figure, it's not going to change anything, it's not going to change the essence of the question. The question is, if we know the sum of these two angles, x and the y, can you figure out z? Answer of course is yes. Z is simply 180 minus x plus y. And if we know x plus y, we can figure out the z. In this case, it's 180 minus 140 or 180 minus 139. The first statement does the job quite nicely. AD, BCE. Because we found out that the first statement by itself is sufficient, we know answer cannot be B, C or E. It will have to be either A or D. If it turns out that the second statement by itself is also sufficient, then the answer will be D. In the second statement, let's take a look at it. It tells us that y plus z equals 108. Now, knowing that y plus z equals 108 will enable us to figure out the value of x, but it does not enable us to figure out the value of z. Simply knowing that y plus z is equal to 108 does not tell us what x is. Second statement by itself is no good. The answer turns out to remain A. And that was the end of that page, number 279. We're not going to start a new page right now. I'll see you tomorrow where we'll begin the new page, okay? Where we'll pick up where we left off, okay? From where we left off. Bye now.